morning to all the participants. We welcome you all to this third day of training program on power transmission systems. Today we will be covering the topics of EHV substations, introduction to EHV substations, and general O&M of AI substations and equipments and its importance. So today's lecture will be taken by Shri Kamal Sarkar sir. He is ex-general manager from PGCIL. He has over 40 years of experience into this transmission system, and he has been associated with CBIP for quite some time now. And he is a well-known expert in the field of transmission system and EHV substations, etc. So we welcome on behalf of CBIP and all the participants, we welcome you, sir, to this training program. And over to you, sir, for conducting today's session, sir. Thank you.
Good morning again to all of you. Before commencing, I would like to have a brief introduction about you, your profile. Just I am not want to know that your name and all this thing, but from which organization you have come and what is your job profile, so that I can modulate my deliberations in that line. I should not go out of the way. That's why I just need it. So please start from your head.
So Tista Valley Power Transmission Limited. Basically, we are in operation and maintenance process. Line is from Sikkim to Kishanganj.
Okay. That you are basically in line person. Okay.
Yes,
next, please.
MD Mutin Ahmad from Tista Valley Power Transmission.
Okay, good. Please.
Hi, I am Kapil Sankar from Tista Valley Power Transmission. I am from line only.
Okay. So my submission is that why all Testa Valley people are sitting together? They should mingle with others also. That is a good opportunity.
Jitendra Kumar,
practices?
Executive Engineer, UPPTCL Lucknow. Jitendra Kumar, Ixian, Executive Engineer, UPPTCL.
UPPTCL. Good. Okay. Next.
Myself, Onpom Bandhavadhyay, coming from TPTL.
TPTL.
Tista Valley Power Transmission.
Tista Valley. Okay, please.
Hello sir, my name is Lokanath. I am from UPTCL. I am working in line design circle.
Okay.
Hello sir, my name is Divya. I am from Uttar Pradesh Power Transmission Corporation Limited.
Good.
I am executive engineer in testing and commissioning.
Okay, testing and
both
commissioning.
line and substation.
Good.
Myself Sushil Kumar Yadav, executive engineer, UPPTCL.
Okay, good representation from UPPTCL.
Myself Pushkar Singh, executive engineer, UPPTCL. Presently I am working in substation design circle, UPPTCL.
Okay, good. Okay.
Hello sir, Mohit Kumar from IndiGrid Limited and looking transmission line O&M activities.
Transmission line O&M, good.
Good morning sir, Samriddhi Gogoi from IndiGrid, and I was in O&M of transmission line. Currently I have been transferred to regulatory, associate of regulatory.
Okay, good. So most of the participants are having exposure in the transmission line, transmission network, transmission system, but very few are having experience in substation equipment, except some UPPTCL. So persons available online. So are you able to follow me? Hello.
Yes, sir.
Hello, participants. Yes, so can one by one can you give your introduction so that I can orient my deliberations in that line. So please go ahead one by one.
Deepak Kumar, good morning sir, Deepak Kumar, NHPC Limited, looking after transmission line design engineer.
Okay, NHPC. Okay, very good. Next.
Good morning, sir.
Good morning.
Myself, Keshav Kishore Jha, Manager Electrical, NHPC Limited, Transmission and Rural Electrification Division.
Okay, rural electrification. Okay, good. Next.
Hello sir, myself Amit Kumar Gupta, Associate Manager, Adani Green Energy Limited.
Okay.
I am looking PSP here.
Okay, good. Next, please.
Hello, good morning sir.
Good morning.
I am Suraj from Adani Group, working in A&D department.
Okay, very good. Next, please.
Hello sir.
Hello.
Sir. Myself Myself, Arnab Chakravarti from PGDC. I am looking after TL assets.
TL assets, okay. Next please. Next.
Good morning, sir. This is Madhuresh Srivastava from Bapcos Limited.
Okay.
I am a Deputy Chief Engineer in Transmission Line.
Okay, very senior person. Okay, good.
Good morning, sir. Good morning. I am Suresh from Kerala State Electricity Board, Deputy Chief Engineer, looking after construction of substations and transmission lines of 220 kV and above.
Okay. Next, please. Next. Okay, please.
Yes, good morning, sir. My name is Mr. Joshi, Deputy from Kerala State Electricity Board.
Okay.
Working as an respective engineer.
Okay, good. Next, please. Next, please.
Sir, good morning. From KP Energy Operation and Maintenance Engineering.
Okay, very good. Go ahead, please. Next.
Morning, sir.
I'm looking for O&M of transmission line.
Okay, O&M of transmission line. Okay, next, please. Next.
Good morning, sir.
Good morning, sir.
Myself, Ganesh Reddy from NSPC, Transmission Division.
Okay, good. Next, please.
Good morning, sir. My name is Shubhal Mandal. I am looking after line engineer.
Okay.
And in India Limited.
Okay. Good. Next, please. Next, please.
Good morning, sir. Rajdeep from Irrigation Limited, currently looking after the NERC transmission.
Okay, good. Next, please. Next.
Good morning, sir. Myself, Mahesh Banode, from KP Energy.
KP Energy.
I'm looking for OMS in Gurugram.
Okay, good. Next, please.
Good morning, sir. Rishabh Desai here from Indigrid Limited, looking after transmission lines.
Transmission lines. Okay. Okay, next.
Morning, sir.
Good morning.
Marg from Indigrid Limited.
Okay.
Looking after O&M of 400 by 220 kV AS substation.
Okay, good. Substation. Okay, good. Next. So done. So most of the
Good morning, sir. Myself, Vijay Kumar Tripathi.
Okay.
I am looking after transmission system, O&M.
O&M. Transmission line or substation?
Earlier I was looking after the line, presently looking after
Substation.
only.
Okay.
In UP power transmission.
UP power transmission. Okay, good. So most of the participants here are oriented towards the transmission line. So it should not appear that what I am telling today regarding the substation equipment, substation design. So this should not be something like Latin and French to them. So that's why I have scripted my presentation here in a very elementary level, not very high standard, so that it goes above your head. So that is the one thing. And whatever questions you have got on these PPTs, you please ask me without any hesitation. I will try to respond every year. But besides whatever is available in the PPTs, I would like to elaborate certain things in detail so that you can get to know a little bit of more insight into the subject. So that is my basic objective. So bear with me. Any misunderstanding, anything if you have during this process of deliberations, please make it clear through me. So I would love that one to respond adequately. So I have got total 7 PPTs today for deliberations to you. So I may not be able to explain each and every point in the presentations, because entire gamut of things I have tried to cover up in the whole substation, regarding the substation in these presentations throughout the day. So I may not be able to deliberate whole issues, all points in my presentation. So if you have got any questions, please ask me. So initially I am going to basic concept of EHV substation. This EHV concept history after Second World War, Industrial Revolution in West is the reason for massive development in the electric power system. EHV system gradually developed subsequent to the World War II. This is the little 1945 you must be aware of. We have seen 132 kV system, we have seen 220 kV system, we have seen 400 kV system, we have seen 765 kV system, we have conceived 1200 kV, HVDC also. Purpose is the bulk power transfer. Bulk power transfer. That is the basic objective. In that direction, so a lot of developments have taken place. Now, what are the advantages? Maximum utilization of available right of way. You see, every transmission line has to have a right of way. 132 kV something, 220 kV something. So all transmission line people must be knowing it, how much meters you have to maintain. Now you see 132 kV system, suppose you remain stagnant at 132 kV system, then number of lines will be much more. So right of way issue, you cannot construct line just like that. So you have to go to higher voltages. You see, higher voltage advantage is what? Transmission capability becomes 4 times if the voltage is doubled, because you know that power is equal to V into I is equal to V by Z, then V square by Z. So proportional is the square of the voltage. But the cost of EHV equipment is proportional to the voltage rating. So whenever you develop something, then there has to be some cost benefit analysis. So people have come to the conclusion, and it is fact also, that for transmission of bulk power, EHV transmission system, development of EHV substation transmission system is the ideal way, so that you get a very low capital expenditure, because the resource is not available in plenty. So capital expenditure has to be optimized. So in that direction, EHV transmission system has given a lot of benefit to the world. Electrical losses, you see, I square R, basic thing. You go to higher voltage, current is reduced, square of that, definitely losses are less. So that is another advantage. Improvement of stability. I am coming to the stability angle little bit later in this presentation, only coming little bit later. Reason is, in a subsequent slide, conductor. It is there, this one. Location of substation, it should be in the center of gravity. Remember one thing, these criteria should be met. Availability of space, you cannot develop your substation, EHV substation in a city. You have to take care that habitation is not affected. You must be aware that because of the high voltage, there are two kinds of problem. One is electromagnetic field, another is electrostatic field. Both have got repercussion on human health. So you cannot have transmission system just like that in the populated area. You have to keep in mind another thing. When you plan a substation, you must ensure that master plan of that area is taken into consideration. Line corridor entering the substation must not be in the populated area, must not be through the populated. Suppose some growth of say a city has to take place. It is available in the master plan. So please consider the master plan that particular location, what is the master plan in future. Accordingly, you plan your location. Now, cost of land is also. Suppose you want to have your substation just on the roadside, cost of land will be very high. So people have gone to the extent that they take a slice for the road. From the main road, they have taken a slice, and then 200 meter or 100 meter behind the road, away from the main road, they have to acquire land to build up the substation. Cost is a very big thing. Resources very limited. You have to plan accordingly. You cannot purchase something that you pay heavy price, and ultimately consumer who have to pay the price whatever you spend. So that's why you need to be very cautious. Nearest to load center, it should not be far away, because you see, if it is far away, then maintenance of transmission line or sub-transmission system, whatever emanates from that substation is going to be troublesome. So it must, and then another things are there, other things are there, voltage drop and all those things are there. So it should not be like that. Availability of road connectivity, you must ensure. If the culvert is there, whether that culvert is having load bearing capacity or not for transporting your heavy equipment like transformer, you must ensure before planning. Otherwise, road construction, road strengthening also will be in your domain. So please take care all these things before planning a substation. It should not so happen that you have chosen a plot of land to build up your substation. That plot is having so much of hindrances like this. If it is a lot of plantations are there, then forest department gets involved. So be careful. You should not, and then suppose some farmers are there, then cultivation is there. We should not occupy some place where cultivation is taking place, because food security is another issue. You must ensure it. So you should not occupy place. So there you try for alternatives. You see, layout you choose is very important. Layout you choose is very important, because space for substation area. You must ensure that not much of land is occupied for this construction, but it doesn't mean that you will compromise with the flexibility. Flexibility, I take two dimensions. Flexibility in operation maintenance, one aspect, and flexibility in future expansion. Load growth is there. The customer growth is going to be there. So today, whatever you are considering, that may not go for and tomorrow, or that be available. It should not so happen. Again, you go for acquisition. So you plan in advance, at least 20-25 years ahead. You please try to visualize what is going to be there. And for that purpose, adequate data, adequate records are available. So you please refer them to understand the size of the plot. But don't compromise on flexibility. This is very, then the reliability. Reliability in operation. Now you see, you have to transfer, suppose, very high capacity transmission lines. Then the busbar selection is one of the things, the most important thing. Based on the busbar selection, space will decide, because busbar product selection will give you layout, and layout means ultimately the space. Suppose you do not require that much of flexibility. It's simple. It is coming and then going. Why do you need to go for double busbar arrangement? Why do you need to go for double main and transfer arrangement? Why you need to go for 1.5 breaker scheme? Why you need to go for a 2 breaker scheme? So everything you have to decide. Nature of load, nature of service, you are required to render. Based on that, you decide. But reliability, don't forget it. Ease of operation and maintenance, I have already said. Adequate clearances must be there. So that tomorrow you want to go for maintenance of one bay, then you require adjacent bay, you shut down. It should not so happen. So adequate space must be available. No compromise on that. Safety is very important. Safety of personnel during operational maintenance and economical. Economical is over everything. You have to consider this aspect when decide the layout. Substations are indoor, outdoor type, hybrid type, compact. You see, certain stations are located in hilly area. Hilly area. You may have difficulty in establishing a outdoor substation there. You may have to go for GIS substations. NHPC, like NHPC has gone for it. Suppose the area where pollution level is very high, then AIS is another problematic area, because there will be pollutants depositing on the insulators. That may create problem for your operation and maintenance. So you may have to go for indoor substation. The GIS is the option. Then suppose everything cannot be indoor, you can compromise. GIS building, something AIS, something GIS, like this, a hybrid mode also you can go. So accordingly, you choose your layout plan and you choose your substation design. Basic concept you design, you choose according to that. Next, busbar, I have said, is very important. Selection of busbar, because you need reliability in operation, you need flexibility in operation. That's why busbar selection is very important. First, buses are two types. One is aluminium pipe supported on bus post insulators. Another is trunk bus. These are the two different normal types available. We are adopting any one of them. Main bus is trunk, and bay buses, earlier days it used to be mostly conductor, and nowadays we have shifted to aluminium pipe for bay equipment interconnections. So everything has got its own advantage, disadvantage, but people have adopted as per the to meet the requirement of reliability. And now you see, rigid type bus bars, supported and post, following advantages are there. I have listed out. I am not going to say, because all these things will be, I think you will be getting copies of this, so I don't need to. But if you have got any question, please ask me.
Because of having lot of advantages.
Yes.
Still we are going for stick type of
Strong bus.
It is typical, because in most of the countries we are seeing that strung type buses are popular. But in our country, I think
now we have shifted. Earlier used to be strong bus. You see NTPC, UPPCL, because you see my exposure in this EHV system, 400 kV system, is with the UP only. So yes. Little bit late. Yeah, in this area, this is a problem.
Disadvantage because of which we are not shifting, only economy is the concept.
You see, maintenance is also another issue. You see, bus conductor, you are taking a connection there. Suppose some loose connection is there, then strands will cut. So that problem is not there.
That is what happening. should go for rigid type rather than.
Yes, we have a lot of utilities. NTPC have gone. I do not know.
Problem being encountered rigid type because we are not
No.
using.
No, that can. But there are problems everywhere. There is something is there. I tell you.
Specific issue because of
I tell you one example. A very good question you have asked. I was sent for after my retirement. I was sent for restoration after Huru. You see, Visakhapatnam. There was a big cyclone there. You see, because of the aluminium pipe, I have seen that all the equipment got flattened because it is a series. Once equipment is falling down, then all adjacent equipment are also falling down. But that kind of scenario possibly will not happen in strong bus system. That is there because there is little bit of flexibility there. But main disadvantage is strong bus is there. Suppose some because of the vibration and all, if you are not monitoring the hotspot of the bus connectors, then you may have problem in that. So
what the problems are there compared to rigid?
Rigid, yes.
O&M.
Yes, because height is also more. You have to
space can be
reduce it. Another thing is that you see you have to strong bus tension is there. Then you see the structure designed. Structure has to be designed. So structure is costly becoming. But in rigid bus, you see bus post insulators you have to put, then foundations, then individual structures.
For very high voltage.
Go for it.
That will be more costly.
More costly, yes, that one.
But up to 20 kV level.
It is rigid, yes. But 4 kV also people are going. In UP initially they were strong bus only. NTPC also initially it was a strong bus only, but subsequently they have gone for the tube bus because ease of maintenance, that kind of conductor cut and all those things, those are not there in aluminium here. So rigid type, what are the disadvantages I have put? But one thing, don't use the CVTs or PTs in place of a bus insulator. Remember it, because they do not have that much of cantilever strength. So because of the expansion, contraction, it may so happen that you will have a failure of the primary terminal of the PT. So you take a tap and then connect it. So people have gone for that kind of concept also, just to save 3 bus post insulators. So they have gone for they have used the CVT for as a bus posting. So please don't do it. Lightning arrestor also in the bay line bays they have put lightning arresters as a support insulator. So don't use it. They have to have. They should be treated as a separate equipment. You put jumper from the rigid bus to equipment. Don't use them. This is because they do not have that much of cantilever strength what you are getting from this bus post insulators. So please remember this one.